So this is the limiting reactants lab. In this lab, you've got your explore section where they just remind you about chemical equations, types of reactions. You've already learned all of these things, so none of that should be new. Then we talk about stoichiometry, which again, you have already learned. It's talking about the numbers in the front. They're showing literally how many of each are doing the reaction, and they're showing them recombining. And then you've got a little question about it. So see, this part you've already learned. It's not new stuff, it's just a reminder. And then they show you a sample calculation. And hopefully, so they're talking about going grams to moles to moles to grams. So they'll show you, like, if you're reacting something like N2 and you can turn it into 0.266 moles, then you can take the 0.266 moles and turn it into moles of H2. Then you can take your moles of H2 and turn it into grams of H2. Now in class, we actually did this as one big long equation. It just depends on your preference. Once you get good at these, it's easier to do it as one big long one into steps, but this lab is going to have you do it in steps. So for example, the lab's going to have you calculate each starting material, and you'll do the mole amounts, and then you'll compare them, figure out which one is the lesser amount, and then you'll also convert them into product. So they've got some examples there if you aren't sure or you don't remember. And then we're going to go on to the actual experiment. Now, the experiment itself doesn't take very long. And, quick note on materials. The scissors, the sheet of white paper, that's to use in the place of white paper. They kind of have a reason behind this. I mean, like any paper would do. And the scissors just to cut into fourths. So you're also welcome to tear it if you can't find any scissors. And instead of a plastic cup, you can just use a beaker. But always have a roll of paper towels because, for cleaning up spills or whatever. All right, so limiting reactants. All right, so in this section, basically what you're going to be doing is a reaction where you trap CO2 gas in a balloon. So the reaction makes CO2 gas. So I'm going to come over here really quick and show the reaction itself. So if you've ever done a vinegar and baking soda volcano, that's basically what you're doing. This is vinegar, which is an acid. It's a very dilute, weak acid. And sometimes they write it with like the H being there. This will be like CH4, CO2. Sometimes you put the H at the end. It's kind of weird how people write acids different ways, and they're allowed to get away with it. But I'm putting it at the front so that you can see it as a double displacement reaction. This is your baking soda. But don't use your own. Use the one in the kit because you paid for the kit, right? So use the baking soda. And I've got this almost completely color-coded here. You can see that the H and the NA switch places. And so what you make, notice that this is a liquid. This is a solid, a solid white powder. What you make, this is dissolved in the water, the liquid. The liquid looks like water. It is actually vinegar is mostly water, with just a little bit of acid in it. So this is dissolved in it. And then you make this, and it appears to be dissolved in it, but actually what it does is it immediately breaks down as soon as it makes water. This is a very useful reaction that we do all the time. So as soon as it hits water, it breaks apart into water, which you won't see because water in water looks like water. And then you're going to make CO2 gas, and that is what's going to blow up some balloons. So that's the fun part in this one. So the two reactants are here, and then the one you're really paying attention to that does all the fun is the CO2. Notice that this reaction is 1, 1, 1, like everything is all 1, so you don't have to worry about numbers, coefficients, messing anything up or changing anything. All right, so a few more lab notes. So you're going to test the law of conservation of matter. That was something that has come up in the lab a few times. Basically, you're going to have all of the parts of the reaction put together, but not do the reaction and weigh it. Get it on the scale, And then after it goes, you're going to put it back on the scale, and you're going to see if the number changed or not. Then you're going to review about limiting reactants, because it might look as though you have the same amount of something in there, but then why is it sometimes you get a more blown up balloon and you don't in the other case? And then note that you are going to be dealing with the mass of a liquid in a test tube, and you're going to have to measure it once it's in the test tube. So you pour it in with a graduating cylinder, but then you have to measure it. So this is why we have the beaker. If this is our scale right here, and we put the beaker on the scale, and then if you take the thing that has the rounded bottom and you set it in the beaker, it's okay if it kind of hits the side a little bit. It's okay if it has liquid in it. That's how you're going to get the weight of it or the mass of it off of a scale. So hopefully that helps some. And then when you're done, always with these, just go ahead and stick them back over here in the 24 well plate. I know you have a test tube rack. In this particular experiment, it works more easily to see everything if you use the 24 well plate. Just kind of keep them a little spread out, you know. Don't put them all like exactly right beside each other. You can always freeze this video if you're wanting to read all of these little parts, but as a little note, sig figs, you're going to be dealing with 2 sig figs throughout almost the whole thing, so you probably want to keep it at 2 sig figs. Let's see. I'm going to keep going on. Here's the reactions. Again, you already saw it. I already went through those reactions. And you are going to have to take pictures. You're going to, one of the times you put the paper on the scale, you're going to have to get a picture. You're going to have a picture of all the balloons to all the test tubes, all in the same picture, sitting in the 24 well plate before, and then you're going to do it after. And then you're also going to have calculations here. Each of those steps have calculations shown at the end of this that you can freeze in this video if you don't happen to already have it in your lab. So these are the steps that have some additional little tips. Directions should say to record each of those masses in the data table. It's kind of implied, but whenever you put something on the scale and you get a mass, like, go ahead and put it in your data table. And there's some calculation help. And before you do the reaction, you're supposed to write down what you think is going to happen. Let's see. Oh, and all the little side note, step 34, don't take the balloons off until you have checked the masses of the test tubes with the balloons attached. That's really big because as soon as you unattach the balloons, your CO2 is going to go away. All right, so you're going to do it like that. They've got them kind of spread out like that. Notice that all the test tubes have numbers on them. Do that, do that, do that. Make sure you number them, number them, number them, number them. And here's what you're going to do once you have them numbered. The acetic acid may not come in this kind of a container. They change up the containers on us, so it may or may not be in a container that looks like that with a lid, but you are going to need a bit of it. So, I mean, not a bit, but like more than like a few drops. So you're going to put the acetic acid in there, and it says in the instructions, if you look, you're going to grab your 10 milliliter graduated cylinder, but you're only going to put 5 milliliters of it. So we're going to fill it up to 5 milliliters. You're going to then take it over, you're going to take it over to your test tubes. You're going to pour it in so that this one has 5 milliliters in it. You're going to do that 4 times. Each time you're pouring this into here, and you're getting the measurement, and then you're filling each of your test tubes. That into there, getting your measure, that test tube, and that one. So far, so good. So you're doing the same thing to all 4 test tubes. So that reactant is the same amount every single time. Now you're going to prep your balloons. Check your balloons before you do it, just for any holes or anything, because it'll be frustrating for you if you have a hole in one of your balloons. So just check it. Be gentle with your balloons. Label them 1, 2, 3, 4. Now these balloons are going to have different amounts of the powder in it. Remember, the powder is baking soda. That's what we're doing. And here's the part where it says cut a piece of white paper into 4 pieces. So you're going to have your paper, and it's just, instead of using weight paper, I'm not sure exactly why they particularly, once you do that, maybe they're just trying to be cheap or something. So basically you're going to have 4 pieces of paper because you're going to weigh something and put it in 4 reactions. And they want you to fold each of them in half, and it's to help get it into the balloons. And I'm going to zoom in on this part right over here. Whoops, that's funny. So you're going to grab your sodium bicarbonate, and you're going to each time have the folded over piece of paper rather than the weight paper, and you're going to measure out 4 amounts. So the first amount, if you look at step 14, it says 0.1, so you're going to do 0.10 grams. That's your first amount. And then this is going to depend. I would be a little hesitant to weigh all 4 amounts all at once. I would go ahead and put it in the balloon, but this one says to place it beside the balloon. My only thing is, like, I don't know what your life is like or what your kitchen is like or wherever you're working, or if it's windy, and I just hate for you to weigh it out and then like lose it. I feel like the balloon's a safer place for it. But anyways, the instructions say you're going to do 0.10 grams of it. You're going to do 0.2 grams, 0.35 grams, and 0.5. Once you get those all weighed out, or individually, whichever way you choose to do it, The whole reason you folded it is because it's going to help you get it into the balloon. Try to do your very, very best job getting it into each of the 4 balloons. Cut that balloon out. So you're going to basically put a little pile of powder carefully into the bottom of each of the balloons. And when you put them on the test tubes, you're going to do it really carefully because you don't want to do the reaction yet. Because you got to get a picture, and you also are going to have to weigh each of them individually before the reaction to see if you've lost any of it. So, because it's hard for me to move things around, I've got a picture of here of what you should expect it to kind of look like once you have it on there. And again, this would be my 0.10 grams, this would be my 0.20 grams, this is my 0.35 grams, and my 0.5 grams. Now, at this point, you got to take a picture of it. And then they also want you to take this thing, and they want you to go back to that beaker and a cup idea, and they want you to put the whole thing on there with the balloon attached. I would kind of tuck the balloon into the beaker with it, you know, so it's not hanging out as much. So maybe that's where your balloon is. They want that number of what that is. Just make sure before you stick it in there that you tear the beaker. So it's like before you put it on, double check that the beaker on the scale says 0. Then you can take each of the test tubes with each of their little balloon amounts that haven't been added yet, and carefully don't add them, but kind of keep it side by side, stick it in there, and get that mass. So this is going to have a mass and you're going to do it with this one, and this one, and this one. Obviously your number is going to be higher than 0.10 because your test tube is included in that mass, and it's going to weigh more than the 0.10, right? Then you're going to put all those numbers in the chart. And then the next thing they're going to be asking about is, hey, why don't you go ahead and do a calculation before you do the reaction? Because you're sitting there thinking, I just want to do the reaction and see what happens, right? That's what I want to do. And look how cool your balloon looks right there. Your balloons are so much cooler than mine. So if you'll notice, step 27, calculate, 28, calculate, 30, calculate, use results. Then they have them attaching the balloon. So they actually have you do the calculations even before you attach the balloon. So I may have jumped the gun on that. You can choose whichever way you do it. Again, I always get nervous that I'm going to knock something off, and so I like to kind of have everything just so myself. You're going to shake the solid in. When you do, you're going to make sure and take as much of this into there as you can. And then this thing is going to blow up and get very big, and same with these ones, but it may not happen the way that you expect. And remember, I didn't actually draw it in this picture, but there was liquid here, so you're actually adding your little powder amount. It's going to go in there and drip down, and then it's going to react. So they're all going to do that. And you want to wait long enough to make sure that they all have kept until like you don't see any bubbling happening here, so you wait till that's done. Then it's going to look something like that. So they're all going to be like different sizes, and you're going to have, this is going to be a little higher because you added some of the powder to it, but there's no bubbling. So then it wants you to get this and do the same thing with the scale, where you have your scale, you have your beaker, they want you to tear it, and then they want you to take the whole amount here, stick it in there. It's all blown up now, so kind of be careful, don't let the balloon unattach. That's supposed to be looking like it's upright. It kind of looks weird the way I drew it. So you've got your little balloon there. But anyways, your balloon's on there, and you get the mass of that. Make sure you get each of those masses before you disassemble everything and put it all away, right? So if you're wondering, okay, well, how do I make predictions? How do I do my math? Here are some math tips. So right here, this is for step 28. This is going to be how you convert grams of the vinegar, that's grams of solution, and it tells you it's 5%. There's some little notes about that, but this math equation in the middle is how you get to moles of C2, H3O2. So each of your reactions will have the same amount because you put 5 milliliters in, remember? Each of them will have the same number for that one. So you're going to have a mole for all of them, each of them, whatever. That's all the same. Then you're going to turn this amount of, that's that solid powder, you're going to add it up on the periodic chart, and you're going to turn that into moles. So that one is going to be different for each reaction. And then the nice thing about this is that since all of the coefficients are 0, the number of moles of this is going to be equal to the moles of CO2 produced. So like before, let's say that this is the smaller number, and it's going to ask you for the limiting reagent. If that's the smaller number, that's fake. This is your limiting. This is your excess. And this is your theoretical yield. Ultimately, they're going to ask you to put that into grams, but you just do it the exact same way with that one. It's 44.01, I think. Oh, it doesn't go there though. It goes on top. This is turning into a longer prelab than I intended. So you'll have the theoretical yield for all of them. But just to figure out which one has the limiting reagent and kind of the amounts, you should have for reaction 1, you should have that comparison. Then for reaction 2, you should have the same comparison, but with different numbers. The top number will be the same, and the bottom number will be different because the first one started with 0.1 grams and the other one was 0.20 grams. So the bottom number is going to be different. So in one of these for sure, a different one is going to be the limiting than the others. So you really do have to compare, and I don't know, say it's this one. This time that's smaller. You cross out the other one, and that means that this is the limiting reactant. So if you do your math before the reaction and you compare your masses of all your CO2s, you can see which ones are bigger or which ones are going to be the same because, and again, I'm making this up, but maybe it'll say that in one case, the reaction will make 2 grams of CO2. Maybe in the next case, the reaction will make 8 grams of CO2. Maybe in another case, it'll only make 1 gram of CO2, and then, maybe the other 0.1 grams. I said those in reverse. So you could tell that this would be the smallest balloon, and this would be the biggest balloon. So hopefully that walks you through how to do them all. I'm going to show the last little bits right in here. Here's that last one again. This series of reactions here, where you convert it into grams, you're going to have that for each reactant, but the vinegar part about it has the same every single time. You can pause on that and look at it. And then here's the last little bit there. And then finally, you've got your question tips. So hopefully this helps. Sorry it's so long.